In this video, we're going to look at example 1 from topic 63, key features of functions. So the example is where we're going to understand domain and range. In part A, they're asking what are the domain and range of the function defined by y is equal to x squared minus 3. So that's already graphed here. Should have little arrows here because this is going to continue forever in each direction. But the idea is that the set of all possible inputs for a relation is called the domain. So we want to figure out what the domain would be, and the inputs are the x values. So we need to ask ourselves, in the equation y equals x squared minus 3, what are we allowed to plug in as our x values? Are there any limitations? And in this case, there's not. We can square any real number. All right, doesn't matter what the number is, any number that you can possibly think of, we can plug into this x value here. So that's it. Any number is allowed to be the input. Okay, so since we can square any real number, then any number can be input for x. All right, so again, there's no limitations on our x value. Next, we want to look at the y value or the range. Right, so we need to next look at the kind of limitations there. So in the range, we're looking at, again, y equals x squared minus 3 and asking ourselves what type of numbers can be our solutions, or what are the either limitations or looking at minimums and maximums. Well, we know when we square this number, or any number squared has to be either 0 or greater. So the minimum is 0 for that x squared term. So if we treat that as y equals 0 minus 3, right, we're looking for some kind of limits, again, minimums, maximums. We know that whatever that is, the lowest it can be is 0. And if we subtract 3 from that, we get y is equal to negative 3. And that's our minimum. All right, we can't go any lower than that for the y value. And if we look at our graph right here, the lowest value is negative 3. All right, the entire graph, that red curve, that parabola, is all above negative 3. Since that it's above negative 3, it matches up kind of what we were looking at here. So we can say that our minimum value, so for our range, we have a minimum value of negative 3. Now, looking at the graph, you can see that it's going to keep going up forever. So there's no maximum value. So we don't have to worry about that. We're just looking at the minimum in that case. All right, so that's the notes and kind of figuring out, what are the limits? Is there a minimum? Is there a maximum? What is the domain? What is the range? And now we want to look at how we can represent that. All right, 'cause clearly this isn't, it's not very clearly stated. So we want to find a little bit better way to show this information. So we're looking here where it says there are two notations used to represent intervals of numbers like domain and range. We have set builder notation, which uses a verbal description or an inequality to describe the numbers. And in this case, using set builder notation, the domain of the function is, so I'm going to write it out and then we'll kind of talk about it. You're going to use these kind of squiggly brackets, and then you would say x, and we could say x is a real number. There are slightly other ways that you could show that, but for now that's going to be kind of the way we'll go with. And to read that out loud, you would say that the set of all x, so we're looking at the set of all x, such that x is a real number. All right, it sounds like a weird way to phrase it, but that's what you would say. So the set of all x such that x is a real number. And now if we wanted to do the same thing using set builder notation for the range, we would again use that little squiggly bracket and would say y such that, and this time we know that the minimum is negative 3. So we're going to use an inequality here, and we're going to say that y has to be greater than or equal to negative 3. Right, because in this case, it is able to be equal to negative 3. So we want to make sure that it's greater than or equal. So to read this one out loud, we would say the set of all y such that y is greater than or equal to -3. There are other slightly different ways to write those in set builder notation, but that's kind of the most straightforward one. So think of it as a verbal description. That's kind of the easiest way to go by that. Now, your second method is interval notation, and you're going to see this far more frequently, and that's really what we're going to use for most of the school year. So an interval notation represents a set of real numbers by the pair of values that are at the left, which is the minimum, and right, or maximum boundaries. So we're either looking at left and right in terms of x values, right, the domain, or the minimums and maximums, which are going to be your y values, which is our range. So using interval notation, the domain of the function is, okay, so the smallest number that we can have, or the lowest number that we can have in the domain, well, we said we can use any real number. So the minimum number is -infinity. And then the maximum number, again, we said any number, so we're going to use +infinity. Now, since you can't actually be equal to -infinity, that's not an actual number, we're going to use parentheses here. And then the same thing with +infinity, we would use parentheses. Now there are instances where we'd use brackets, not parentheses, and we'll get to that when we go through this chart below here. But the idea is we're looking at the lowest and the highest values, so -infinity to +infinity for our domain. Now our range, we know that the lowest value is -3, so that would be the minimum value, and the maximum value, the highest, we said it can go up forever, so that would be a +infinity. Infinity symbols are always going to have parentheses because, again, we can't be equal to infinity. Infinity is not actually a specific number. And -3, since we can be equal to -3 in this problem, instead of a parenthesis, we're going to use a bracket. So using interval notation, the range would be -3 to infinity, but we'd have that bracket with the -3 because we can be equal to it. And infinity symbols, negative and positive, will always have parentheses. Let's take a look at the chart. This chart will just summarize things for you. I'm going to kind of go through a little bit quickly. You can go through more detail on your own. But what you want to look at is take note of the symbols that are used on each side. And if we look at this, the words all real numbers greater or equal to, less than or equal to. So that equal to is kind of telling us the brackets there. That's key. And if you look at the second example, greater than 3, that's where we wound up with a parenthesis. Sorry about that. Less than or equal to 4, that's where there's a bracket. All right, so do be careful of that. When you go through this, take a close look at this and make sure that you are careful with whether you should be using brackets or parentheses. Again, interval notation will be used far more frequently. You'll kind of see set builder notation, but it tends to be a little bit more cumbersome. Interval notation, very straightforward. And if you look at this bottom one, I want to point that out. All real numbers, right? We'd have -infinity to +infinity. We talked about with our that with our domain. And just one more time, this is really important thing. Here, in this case, let's look at this one. We have greater than or equal to 3. So that's why we have this bracket here. Whereas in the problem before, it just said greater than 3, which is why there's a parentheses. Okay, so do keep that in mind. Review this chart. This chart will give you a pretty good understanding of when you should be using parentheses and when you should be using brackets. It also has the set builder notation on the right. Be familiar with it, but once again, interval notation is really the way to go. You'll see that a lot more in this course. So be more familiar with interval notation and just kind of keep set builder notation in the back of your mind. In this video, we're going to look at topic 63, example 1, part B. So we're told an air tanker flies over a forest fires and drops water at a constant rate, so constant rate of 400 gallons per second until its 8,000 gallon tank is empty. What are the domain and range of the function that represents the volume of water the air tanker can drop in X seconds? All right, so the first thing we need to do is we need to figure out the function. So we need an input value and an output value. So the input would be our x value. So the input is the seconds, or the number of seconds that this water is being dropped. And remember, that is our x value. And then the output would be the volume of water dropped. All right, how much of this water has been dropped? And that would be our y value. So the function y would be equal to, well, we're dropping the water at a constant rate of 400 gallons. So 400, and then we would multiply by the number of seconds that we've been dropping the water for. So y is equal to 400x. And again, y would be the total water that we've dropped. You can also write this as f of x is equal to 400x if you wanted to show it as a function. Okay, so let's look at the domain. We need to find minimum and maximum values. So for the domain, remember domain was our input, our x values. So we have a minimum value. Well, if we're dropping water and it's in terms of time, our minimum value would be 0. Right, you can't drop water for less than 0 seconds. So I couldn't say, oh, I dropped water for -5 seconds. That doesn't make any sense in this case. So the minimum value would be 0. The maximum value isn't as straightforward, but isn't too difficult to figure out. The maximum would be, what's the longest amount of time that we can drop water for? Well, we know that we have 8,000 gallons of water. And we know that per second, we can drop 400 gallons. So if we do 8,000 divided by 400, that would give us 20. So the most amount of time we can drop water for is 20 seconds. After that, we run out of water. The tank is going to be empty. So the maximum amount of time will be 20. So my domain, pretty straightforward. Using interval notation, we know the smallest is 0 and the largest is 20. Now we just need to ask ourselves, can we drop water for 0 seconds? Yes, so we're going to use a bracket. And can we drop water for 20 seconds? Yes, that is our absolute max. So we're also going to use a bracket. We don't want to use parentheses in this case. We would use brackets. So the domain is solved for. Now we need to look at the range. And the same thing, we need to find a minimum and maximum. Remember that the range is the amount of water that we've dropped. So the minimum, what's the least amount of water that we can drop? Well, we can drop 0 gallons of water, right? We don't actually have to drop the water. I mean, we should if there's a forest fire, but the minimum would be 0. Okay, it is possible to drop 0 gallons of water. Now, we need to figure out the maximum capacity. What's the maximum that we can drop? Well, this is pretty easy because we only carry 8,000, or not only, 8,000 is a lot, but the maximum would be 8,000 gallons. Okay, that's the most amount of water that we could possibly drop, and that would be after that 20 seconds. So the range, again, we're looking at minimum of 0, maximum of 8,000, and since we can be equal to those two, we can drop a minimum of 0, we can drop a maximum of 8,000, we would use brackets. Highlight the wrong thing here. And then the range would be 0 to 8,000. You could also write these in set builder notation, but as I mentioned in the last video, we're going to use interval notation far more frequently in this course, so I'm just going to stick with that as often as possible. The only time I would use set builder is if they specifically ask for it, and I can't really think of a case where they would do that. All right, interval notation is a better method. Stick to that. And that's it. All right, so you have your domain and your range.